Good morning. This is Ms. Parks. We're going to be talking about triangles and lost signs today. So we're going to be able to solve triangles. And when it says solve a triangle, we're going to find the measures of the three sides and angles. Okay. And you can do this as long as you know three different parts usually. And so for lost signs, for today's lesson of lost signs, they're going to be giving you two angles and a side. Okay, two angles and a side. Those are the easier ones, and I'll show you how to do this. So lost signs is sine of A over A equals sine of B over B equals sine of C over C. It's actually the easiest way to solve everything. They don't have to be right triangles, and you can solve a majority of the triangles by using lost signs. All right, so capital A, B, and C are the angles, and lowercase a, b, and c are the sides, and they're across from one another. So, for example, I'm just going to draw a picture. Normally, you don't really need a picture, just so you know. So, if this is angle A, and it's 32.3, and then this is side A, then it's across from it, centimeters. All right, and then angle B is, let me make a different color here. Angle B is 81.8 degrees, and side B would be across from it. And then angle C is whatever angle C is, which we could figure out right now. And then side C is across from it. All right, so let's fill in everything that we know. A is 32.3 degrees. Angle B is 81.8, and side A is 42.9, and that's centimeters. I'm not going to be super picky about the units. I'm actually going to leave them out when we go to do quizzes and stuff, just so that I can focus you on doing the work. Of course, on word problems, the units are very important. All right, so the two parts that we know the sides for, or we're going to use that. So because I know A and side A and angle A, then I'm going to use sine A over A twice. The first thing we're going to do is go ahead and find the missing angle just by adding the two regular angles together and the two angles together, and subtracting them from 180. So this is 65.9 degrees. You don't need to show the work. And again, I'm going to put this here so you can kind of see it. If this is angle A, that's side A, angle B, side B, B. And if this is angle C, that's side C. Okay, they're across from each other. All right, so there'll be two formulas that you need to use. Both of those formulas must use this. Okay, so sine of A over A is equal to, and then we're going to do sine of B, which is 81.8 over B. Same thing, we're going to use sine of A over A, and then we're going to use equal to sine of C over C. Then all we're going to do is cross multiply, and you'll have your answer. So you're going to multiply this times this, and then you'll divide by sine of 32.3. So you don't really have to show this work. I'm going to show it for the first time, just because this is the first time we're doing this. So sine of 32.3 times B. And then you'll divide both sides. Move this out of the way. You'll divide both sides by sine of 32.3. So you don't have to show all of this work. All you have to do is show the original equation, and then you multiply these two together and divide by this one. All right, so for B, you should get 79.5. For C, Same thing, we're going to multiply these two together. You always multiply the two that are diagonal from each other that have numbers in them, and then we'll divide by this. So C is equal to 73.3. What you should notice is that the shortest side is across from the smallest angle. Okay, and that's all you have to do. So you, again, need to make sure that the angle and the side that are given is the formula that you use twice. Okay, so if you actually set this up like this, and you put the A in the middle, so you did sine of B over B, sine of A over A, and again, let me move this a little bit, and sine of C over C, you could, this is sufficient work for me. If you just showed that, then what you would do is you would cross multiply here, and you would cross multiply here. So as long as you know how to do the math, then this formula is enough. Okay? And we're going to round everything to the tens place. You're just going to do everything in your calculator. Don't round in the middle part. Go ahead and try the next problem, please. All right, here we go. So for this one, again, you don't really need to draw the triangle. So we have 28.8 degrees. C is 102.6 degrees. And C is 25.3 inches. So the first thing you do is find the third angle. That's the missing angle. So all the angles have to add up to 180. And this is the one that you know both the side and the angle to. So that's the one we're going to use for both. So I'm going to have sine of 102.6 over 25.3 is equal to sine of A over A. Same thing, sine of 102.6 over 25.3 is equal to sine of B, which is 48.6, over B. So multiply these two together, divide by that. A is equal to 12.5. Same thing for the next one. Multiply these two together, divide by this, divide by that one, and for B, you should have 19.4. If you need to do that the long way and multiply that out, if it makes more sense to you to do 25.3 times sine of 48.6 equals sine of 102.6 times B, and then divide both sides by sine of 102.6, and then do all this, then go ahead and do that if it helps you. All right, so if you have a ruler, it will be helpful, and obviously a calculator. So let's go ahead and set this up and see how it goes. You don't know what the picture looks like before you start, so it's possible that the picture is going to go like all over the place. It might go further down than you want or further up than you want, but you'll get the idea. All right, let's read this. Two ranger stations are on an east-west line 110 miles apart. Okay, 110. A forest fire is located on a bearing of north 62 east from the western station. So again, north, south, east, and west. So from the western station, this is the western station, and actually let me draw this in. All right, so we have north, 62 east. So from north, we're going to go 62 degrees east. And that's where a forest fire is located, somewhere along this line. And try to draw it to scale. We don't know where on that line it is, but it's in that direction. Okay? Next. Western Station A. So we'll call this A. The next one, it says a bearing of north 15 east from the Eastern Station B. So this is B. Let me just go ahead and use this. And it's north, and then 15 degrees east. It's still east. It's still going to the right. All right, so that means that the fire is out here. That means the fire is out here, and I would like you to actually label A, B, and fire. Now we need to use this triangle to figure out whatever the question's asking, which I haven't even read that part yet. Okay, so we're going to use that triangle. You can't use that triangle until you know some of the information in the triangle. Okay, so I do know that this angle down at A, the whole entire thing is 90, which means the angle next to it is 28 degrees. I also know that this angle here is 90, and this angle next to it is 15. So this entire angle from here to here is 105. So if you want, you could just draw that triangle to the side. 105. 110 and 28. So the angle that's missing up at the top is 47. The question, how far is the fire from the Western Station, means that this is X, because A is the Western Station, that's the fire, that's B. They want us to find that length. So we'll do sine of 105 over X. Okay, and then we have to do sine of 47 over 110. If you cross multiply here, you multiply these two together, divide by that one, you will get X is equal to 145.3 miles. That's how far the fire is from the Western Station. You need to make sure that if you're solving for X, that X is in your picture. Otherwise, you leave it up to the reader to figure out where X is, and that's not okay. So if you're going to use X in your equation, you need to have an X value in your figure as well. Okay? So you guys try the next problem and see how you do. It's a little bit different, but just do the best you can. If you get stuck, then just play a little bit of the video and see if you can get caught up a little bit before you actually finish, okay? All right. So you have to be careful when you read these things, okay? So it says the bearing of a lighthouse from a ship was found to be north 52 west, okay? So I don't know which way this picture is going, so I'm just going to put the ship in the middle. The lighthouse is north. That's terrible. North 52 west. So north, and then 52, which is about halfway. So I'm going to put a 52 here, west. And I'm just going to draw it freehand. And I'm just going to extend this out. The lighthouse is somewhere on that line, okay, from the ship. Then it says the ship then sailed 5.8 kilometers due south. Due south means exactly south. So the ship has now gone south 5.8 kilometers, and now the ship is here. So I'm putting 2 for the second place the ship is. So the ship started here, now it's moving south. And now the new bearing to the lighthouse is north 23 west. So from this new place, this new location, my bearing is north 23, which is smaller, west. So the lighthouse is where the two lines cross, right there. Okay, so here's what I have. I'm going to draw the picture to the side just because it'll be easier. Okay, so I have 5.8, which is straight up and down. I have this line and this line. Okay, so this is the triangle I'm using. Okay, so this is where the ship was first, this is where the ship was second, and this is where the lighthouse is. I know that this angle right here is 23 degrees. I know that this angle here is 52, which means that if this is a straight angle here, which it is, and if this part of it is 52, let's put this over here, 52, then the angle on the inside would be whatever's left of 180, because that's 180 degrees from here to here. So that angle has to be 128. Now I have two angles inside that triangle, which means that the third angle is 29. And now I have to figure out, it says, find the distance between the ship and the lighthouse at each location. So they actually want me to find this and this. I'm going to use two different variables. Okay? So here we go. Using this, I'm going to do the place where I actually have values on each side is the 29 and the 5.8. So that's the one I have to use twice. So sine of 29 over 5.8 is equal to sine of 128 over y. That's this part. And sine of 29 over 5.8 is equal to sine of 23 over x. So make sure you have two different variables, that you don't have x twice. Okay, so my x value in the picture is 4.7 kilometers. And the y value in the picture is 9.4 kilometers. If you drew your picture close to scale, then that should make sense. All right. So I know the pictures are difficult. They will take some practice, and hopefully you'll understand how to do them as you go. Okay, you're going to give yourself some room to do these pictures and try to draw them to scale as much as possible. The last part of this section is finding area and not using the old formula that we're used to doing, which is 1/2 base times height. Not that that doesn't work, but when you're using these formulas, basically, as long as you have an angle, and that angle is between the two given sides of a triangle, then you can find the area. Super easy. It's 1/2 the two sides multiplied together. I don't even care if they're called ABC, PQR, whatever it is. So as long as the angle is between the sides, that's the most important thing. You have to have side, angle, side that's given. Okay? Then you multiply 1/2 times the two given sides, 34.3 and 42, and then sine of the included angle, it's called. And then if you multiply all that together, you get the area of that triangle. So the area of the triangle is 591.5 square feet. Now, when you're doing this, I think that you can even use 0.5 right there for the 1/2, or you can multiply all these together and then at the end divide your answer by 2, however you want to use your calculator, okay? All right. That should be easy enough. The biggest thing to remember needs to be side angle side. If it's not side angle side, then you probably have to use law of sines to figure out one of the sides for one of the angles. All right, go ahead and try example 4 and then come play your play the video after to check your answer. All right, we have side, we have angle, and we have side, okay? So it's in between. So all we have to do is 1/2 times the two sides, it doesn't matter what order they're in, times sine of the angle. And so the area is 47.2 square feet again. All right, easy enough. Now let's do the next one and see what happens. If you look at the next problem, there's a couple things that we have to work on. First of all, I'm going to redraw this. And the reason I'm going to redraw this is because I don't want it to be in degrees and, in minutes and seconds. So in order to change that, this is going to be 24, and then we're going to take 45 and divide by 60, and that's going to give me 0.75, okay? So that's the angle. And then here, I'm going to have 52, and then we have 30 over 60, so that's 52.5 degrees, all right? We also have this side right here that's given 27.3, but we need side angle side. So you have two choices, okay? Your two choices are, you can do side angle side, okay? Or, I lost the 3 here. You could do side angle side. Okay, so you have to decide which of those you want to do. It's up to you. So I'm going to go ahead and do, I guess it doesn't really matter. I don't know, I'm going to do this. So I need to know this side and this side and this angle. So in order to do my area formula, let me call this A, or actually I'm just going to put a blank there for now. It's going to be 1/2 the side I don't know times 27.3 times sine of 24.75. So I'm using this. But I need to figure out that side. So in order to figure out that side, I'm going to call that X for right now. I'm going to use the law of sines. So I will use sine of 52.5 over X is equal to this angle right here, 102.75. So sine of 102.75 over 27.3. So when I do that, when I do this cross multiplication here, this times this, divided by this, I should get X is equal to 22.2. Now these are centimeters. Okay, 22.2. So that means that goes here, 22.2. All right, that was X. And so if I multiply all that together, you get about 126.9. Now, let's say that you found this side instead, because these are rounded values. You might have a number that's a little bit different than this. I think if you ended up finding this side instead, it was 11.7. And so if you did 1/2 of 11.7 times 27.3 times sine of 52.5, let's say you did this side angle side over here, then your area would have come out to be 126.7 centimeters squared. It's still pretty close. It's not exact because we're rounding things. All right. So that covers it for section 7.1. And we'll do some practice problems on this, and we'll do more law of sines in the next section.